Hello everyone, this is 𝗟𝗲𝗃𝗲 and welcome to Smart Indus YouTube channel, your one-stop solution to ace your tech interviews. Today we are going to solve the latest CodeChef contest, Starters 172 problems. So let's dive in.
Okay, so let's quickly start with the first problem of starters 172. And the given problem statement is Chef is currently in the year X in Chefland. He has a time machine that allows him to travel at most 25 years into the future, but he can use it only once. Determine whether Chef can reach the year 2050 with a single use of the time machine. Okay, so don't worry if you don't understand problem statement. Let's go through sample input output and let's understand the question. So if you see, chef is given current year and he is given time machine. Okay, and with the help of the time machine, he can travel 25 years into the future, and he can only travel once. Okay, so from the current year, we should check whether he can go into year 2050. So for first sample input 2050, it is already 2050. Okay, so it is yes. So for sample input 2000, even if he travels for 25 years, he will reach to 2025 year. So it is no. Again, for 2030, if he travels for 20 years, he can reach 2050. So yes. Again, same for 2025. Okay. So what can be the logic? Simply, if if X is current year and if we add plus 25, if it is greater than or equals to 2050, we can simply print yes. Else, we can print no. Okay. So I hope everyone clear with the problem statement and logic. Let's quickly write code for this. Okay, let's write code for first problem. So simply, what is the input? We need to scan current year. So let's say take some variable x. Let's scan current year. Now, what should be the logic? If x plus 25, if this value is greater than or equals to 2050, we can print yes. Else, we can print no. Okay, let's run the code. Let's submit the code. Okay, let's move forward. Let's go through the problem statement of second problem. So the given problem statement is chef has x1s and y2s in his collection. He wants to arrange all of them into smallest possible palindrome number. Using all of these ones and twos, help chef with the answer. Note x and y are both even numbers. Simply, what is the given problem statement? So chef is given x1 and y2s. We need to arrange this number such a way we should be able to form smallest possible palindrome number. What is palindrome? So palindrome is nothing but it is a number that remains the same when its digits are reversed. So if I give you a simple example, this is palindrome and this is not palindrome. Similarly, this is palindrome. This is palindrome. Okay. Now let's see what we can do with this problem statement. Now given sample inputs are we are given two one and zero twos. So we need to arrange them such a way that it should be palindrome and it should be smallest possible. So we have no zeros. We only have two ones. So the only possible number is 11. So we'll simply print it. Okay. Similarly, if you look at the second sample input, we are given two ones and two twos. Now, how many ways we can arrange them? So there will be multiple ways, but what are the different ways we can arrange them such that they remain palindrome? So can I simply say one, then twos, then one, again two, one, one, two, something like this? Yes or no? So what is the smallest value out of these two? This will be the smallest value. So we'll be printing it. So to keep it short, every time ones and twos are even. To get smallest value, what we can do? Can I simply say smallest value will be determined by most significant values? Yes or no? So if you take which number is greater? Why? Because this digit, the second number is having greater value and first number is having smaller value. That is the reason why second number is greater. No matter, and once this digit is smaller than this digit, we don't bother about rest of the digits. Yes or no? So to get smaller number, let's take a different example. Let's say we are given 4 ones and 2 twos. So can you tell me what can be the smallest possible number which is still palindrome? Okay, having ones and twos. So can I simply say it will be nothing but two ones, then two twos, then two ones again. Similarly, if we are given two ones and four twos, in this scenario, can I simply say it will be one, then four twos, then one? Yes or no? If you look for any other combination, in this case and in this case, okay, we will get a palindrome, but the value will be definitely greater than that. So how are we getting this? So can I simply say if we are having x ones, we are having we are having x by 2 ones, then y 2s, then again x by 2 ones. Similarly here, x by 2 1, y 2s, then x by 2 ones. Yes or no? So only this combination will give us smallest possible value. Okay. I hope everyone are clear with logic. Let's quickly write code for this. Okay. Let's quickly write code for second problem. So we are scanning t and we are looping for t times. Every time we are scanning x and y, then we are calling function print answer. Okay, we are not returning anything. We are directly trying to print it. So how will our logic look like? So can I simply say we are iterating for x by 2 times. Okay, and we are printing 1. Then again, can I simply say we are iterating for y times and we are printing 2. Again, we are iterating for x by 2 times. We are printing 1. Finally, let's print and done. Okay. Now let's try to run code for this. Okay, let's submit the code. It got successfully accepted. Let's move forward. Okay, let's discuss third problem. And the given problem statement is the streak value of an array is defined as the maximum length of non-decreasing subarray, more formally. So if you look here, we are trying to calculate streak value of array B, and it is defined as the maximum length of non-decreasing subarray. So firstly, what is subarray? So if you're having array something like this, so subarray is nothing but non-empty continuous part of array. Okay, non-empty continuous part of array. So if you take 2 and 3, it is subarray. If you consider 5 to 3, it is not subarray. Why? Because it is not continuous. Okay, so that is subarray. And what is non-decreasing subarray? So if I consider 2 and 3, is it non-decreasing? So can I simply say after 2, 1, it is decreasing? Yes or no? How about 139? So can I simply say it is not decreasing at any point of time? So it is called as non-decreasing subarray. So even if you have 9, still it is a non-decreasing subarray. Even if it is equal, it is fine. Okay. So here it is mentioned that when you are having two indices I, j, where j is always greater than or equals to I, all the elements should be either greater than or equals to previous element. Okay. So that is non-decreasing subarray. So in this scenario, can I simply say this is the maximum length subarray? which is non-decreasing. Okay. Now let's move forward. Chef has an array A of length n and a magical number x. Along with array B, Chef is having array A of length n, okay, and magical number x. You are allowed to perform the following operation at most once. Select an index I, select an index I, and update the element at A of I. Okay, so Chef is having a array A of length n and a magical number x. Okay, and we are allowed to perform the following operations at most once. So every time we can choose an index A of I, we can multiply A of I with x and we can update A of I. Okay. Now your task is to find the maximum possible streak value achievable for an array. Okay. So let's go through sample input output and understand problem more better. Okay. So here if you observe, the given constraints are t ranges from 1 to 10 power 3 and n comma x ranges from 1 to 10 power 3 and a of I ranges from 1 to 10 power 5. And if you observe this line, what this line says, the sum of n over all test cases won't exceed 10 power 3. Okay, so it means if you are having some scenario like t into n square, as per given constraints, will it work or will it give you TLE? So as per given constraints, if you consider the maximum value of t, it is 10 power 3 and maximum value of n is 10 power 3. Whole square will be total 10 power 9 iteration. Okay, so ideally it should give TL. But in this scenario, what they mentioned, the sum of n over all test cases won't exceed 10 power 3. That means t plus n, it will not exceed 10 power 3. Okay, so it will not have case something like t is 10 power 3 and at the same time all n values will be 10 power 3. So even if you write the code with this time complexity, still it won't give you TLE. Okay, that's the point. So it will be something like 10 power 6 iteration. Okay, so let's move forward. And if you see for first sample input, it is nothing but we are given array A of size n. The elements are 1, 2, n is nothing but 5, 1, 2, 1, 4, 2. Yes or no? And you're given x as 3. Now what we should do is we should find maximum subarray, maximum non-decreasing subarray. And the small twist here is so if you consider a subarray starting from 1, so can I simply say non-decreasing subarray starting from 1 will be 1, okay, and 1, 2. And can we take 1 to 1? No, right? So can I simply say 1 and 1, 2 are two subarrays starting from 1, which are non-decreasing. Similarly, from 2, can I simply say 2? Yes or no? And similarly, from 1, we can say 1, 1, 4. We cannot have 1, 4, 2. Again, from 4, only 4. Again, from 2, only 2. But now, if you observe, what is the maximum length that we got? 2. But if you observe output, it is 4. So what we can do is we can pick a number when we are forming these subarrays. So let's say the subarray starting from 1 are 1, 1, 2, and when we come across 1 to 1, okay, we have liberty. We can pick an element. We can multiply that with 3. Okay, so in this scenario, 1 is less than 2. Now what we can do is we can do 1 into 3, and we can do it as 1 to 3. Okay, now again 1, 2, 3, 4 will be next subarray. Again 1, 2, 3, 4, 2. Again, can we multiply this 2 with 3, and can we make it 6? No. The point is only we can multiply with x only once. Okay, you're allowed to perform the following operation at most once, only once. Okay, so we cannot do this. So this cannot be a subarray. Okay, now what's the maximum length that we can get? Can I simply say this will be the subarray? So the output is 4. Similarly, look for second test case. We are having a of 3, that is nothing but 2, 5, 3. So subarray starting from 2, 2, 5. Then for 2, 5, 3, we can multiply 3 with 10. We can make it 30. Yes or no? So 2, 5, 30. The maximum length is 3. Again, if you consider third subarray, so if you consider third subarray, sorry, my bad. If you consider third sample input, A of 4 is nothing but 90, 2, 5, 6. Okay. So starting from 90, can I simply say 90? Again, 92, 2 is smaller, and even if you multiply 2 with 5, can I simply say it will be 10? But still, it will be it will not be non-decreasing. Yes or no? So starting from 90, only 90. So for 2, we can have 2, then 2, 5, then 2, 5, 6. So here we didn't need 5 to multiply with any index. Okay. So the maximum length will be 3. If it is something like 2, then what we can do? We can multiply this 2 with 5 and we can make this 10 and we can have 3. Okay. Now, I hope everyone are clear with problem statement. Now, how can we solve it? So, can I simply say first thing we should do is uh, we should create subarray. Like every time, we should be looking for a subarray starting from each index, starting from 0 index, then starting from 1 index, then from 2 index. Okay. So, for every index, we can keep traversing. Every time we can have previous element. Yes or no? So, let's say if we take example 1 to 1, 4 to, can I simply say this is 0th index, first index, second index, third index, and fourth index? We can start from here. Okay. Every time we can maintain some previous value. So let's take it as -1 here. Okay. Now, current element, if it is greater than previous, what we can do is we can update the previous with current and we can keep moving this forward. Okay. Again, greater than previous, then we can update this, we can move forward. Okay, again, is it greater? No. But in this scenario, what we can do is we can multiply this value with x. So the current value will become 1 into 3, 3. This is greater than 2. But at the same time, we can apply only once. So for that, we can have some flag variable which is initially true. That means we can apply. Okay. So once we're done with this, what we can do? We can make it false. Okay. We can make it false, and we can update this previous and we can keep moving forward. Again at 4, the current will be 4 and it is greater than previous, so we can move forward. We can update previous. Okay. Now 2, if you observe 2 is smaller than previous, but can we multiply with x? No. Why? Because flag is false. So can I simply say, and if you observe, like we did for only 1, starting from 1. So we should do the same for starting from 2, starting from 1, starting from 4, starting from 2. So let's only bother about starting from particular index, 0th index, let's say. So can I simply say it can be something like this? So we will have for int j equals to 0 to j less than n, j plus plus. Yes or no? Now, every time when we are moving forward, can I simply say we need to maintain previous, which is initially -1. Okay. And can we maintain flag, which is initially true? Yes or no? Now, every time what we can do? We'll be having 3 scenarios. One, if current element, if current, let's say G, if current element is greater than or equals to previous element, then can I simply say we can update previous, with array of J, and can I simply say we need to maintain some count that so that we'll get number of elements in subarray. Okay, we can also do J minus I plus 1, something like that, but it's better to have count. So let's increment count when we done this. And what is the other scenario? Can I simply say index 2 when the current element is greater, when current element is smaller than previous, but still flag is true. Okay. So in this scenario, what you can do is the current element is not greater than or equals to previous, but flag is true. So if flag is true, can I simply say, if flag is true and if array of j into x is greater than or equals to previous. If this is greater than or equals to previous, can I simply say we can update, again we can update our previous with array of j into x, and can we increment count? So along with this, we should also make flag as false. And if you don't satisfy any of the condition, what we can do? We can simply break. So finally, what we can do, every time, whatever count we are getting, we need to update, yes or no. So we need to have another variable answer, okay? And we should keep updating max. And we should be doing the same thing for n elements. So we'll have another loop here for I equals to 0 to n minus 1. And here we are not starting from 0, we will be starting from I every time. And we'll maintain some answer variable, which is initially 0. And every time we'll update answer equals to maximum of answer comma count. And finally, we can return answer. Okay, very clear. So let's write code for this. So here we are simply having t, then scanning t. Then every time we are taking n and x, so we are scanning the size of array and x. Then we are taking array of size here, we are scanning it, and let's say we are calling function called streak, and it will return some value. It will return the streak, and we'll print it. Okay. So what logic should go into this streak? So can I simply say, firstly, we are doing for one index in j equals to 0. Let's say if we are starting from 0. Every time, what we require? One is previous, which is -1. Then what else? Count 0. What else? Flag true. Okay. Now we will be having three conditions. One, if array of j is greater than or equals to previous, then we simply update previous. Okay. And we'll increment count. What is the other condition? Else if flag is true and current element into x is greater than or equals to previous. Then in this scenario, we will mark flag as false. Then we'll update previous with array of j into x. After updating previous, you need to increment count. Okay. Else, what we'll be doing? Else, we will break. Okay. So this we should be doing for not just starting from one. Sorry, not just starting from 0th index, but starting from every index. So on top of it, we'll have another loop. Okay. And every time we'll be starting from I, and we'll be traversing till n. So let's have it within this for loop. So we'll maintain some answer variable. After for loop, we'll simply update answer with maximum of answer comma previous. Sorry, count. Finally, we can return answer. And my bad, we shouldn't have it here. We should have this inside this one. Okay, let's run the code. Okay, this is the expected output. Let's update. Okay, let's move forward. Let's discuss fourth problem, and the given problem statement is if gives you two strings A and B, you can perform the following operation on A as many times as you want. Okay, remove character AI from the string A. This has the cost of I, which is the index of the element that you are removing. Note that cost is always equal to the index in current string and not the original string. So refer to the sample test case for example. Okay, you have to print the minimum cost of transforming A to B using the above operation. If it is not possible to transform string A to B, print -1. Okay, so let's go through sample input output and let's understand better. So you are given, if you take first sample input, you are given two strings A, let's take of size n, and the given string is 𝗟𝗃𝗃𝗃. Okay, let's take it something like this. Then string B of size m cd. We need to transform this string to below string. Okay, if we cannot transform, we need to return -1. If we can transform, for transforming how much cost it is taking, we need to return minimum cost. So how will we calculate cost? So simply if you are having ACCD, the indexes are something like this. It is one based index. Now you can delete one character from this. You can to get CD, can we delete D? It is not possible, right? If we delete D, we cannot get B. So can we delete C? We can delete one of the C. So what if I delete this C? The cost will be 3. Yes or no? And the transform string will be something like this. Now again it is not equals to B. Can we delete this G? No. Can we delete this C? No. Can we delete this A? Yes or no? And for deleting that, again it will be index plus 1. Okay. So the cost is 4. Now let's say I delete it differently again. So can I delete, instead of deleting this C, can I delete A in first place? So can I simply say now the cost of deleting A will become 1 plus, now the transform string will be something like this, and indices for this transform string is this. Now again, can I delete this C? Yes or no? And cost for deleting this will be 1. So the string will become this. So can I simply say it is nothing but it is equals to B? Okay, and what about cost 2? So every time while deleting, for deleting a particular value at index, the cost will be that index. Okay, and after, like for deleting that value at that index, it takes that index cost, and we need to minimize it. Okay, so everyone clear? Let's see other two sample input output. Now again, A, B, C, D, and ED. Firstly, if this is string A and if this is string B, is it possible to convert string A to B? No, right? Because E is not present in A. So in this scenario, we need to return -1. And let's go through last sample input. We need to convert this to double A. Yes or no? So A of n is 4 A's and 3 B's, and B of m is 2 A's. Now we need to convert A to B. Okay. So can I simply say this is string and these are indices? Now can I simply say, to get string B, what characters we can delete? I can say we can delete these 3 characters and we can delete any 2 characters from it. So what are the characters we should delete so that the cost will be minimum? So can I simply say we should delete first 2 characters of it. Okay, why? Because if you see, first if I delete this, the cost will be 1. Now the converted or transformed string will be this. Okay, again if I delete this, again cost will be 1. Again transform string will be something like this. Okay, now again if you can you delete this? No. Now what it should be deleting? Can I delete this? No. Now can I delete this? Yes. So the cost will be 3 and the transform string will be something like this. Again can we delete this? Yes. Again the transform string will be this. Now again delete this, this will be this. So what is total cost? 9 plus 1, that will be 11. So 11. Yes or no? Now how can we solve this? So instead of AB, let's take AB. Sorry, instead of AA, let's take AB. Now let's try to transform. So what should be the expected output? Can you tell me? Can you tell me can I transform string A to B? I can transform. Yes or no? Now, if I can transform, which indices or which values I should be not deleting in string A, then I will get minimum cost. Can I simply say the last occurrence of B, yes or no, and the last occurrence of A? If I don't delete these two values, then I will get minimum cost. So no, because if I have this A, if I have this A, and if I delete these values, okay, every time how it will look like, every time the deleting element will become index 2. So it will be 2 plus 2 plus 2. If I, if I have, if I have, if I keep deleting starting element, okay, it can I simply say it will be 1 plus 1 plus 1, which is minimal cost. So to get minimal cost, I should delete minimum index value. For that, I should I shouldn't delete the value which is at highest index. Yes or no? So in this scenario, this A and this B I shouldn't be deleting. So how can we figure out? How can we figure out which indices we should be deleting and which indices we shouldn't be deleting? Okay. So first let's figure out what which indices we shouldn't delete. Okay. Then let's go for solution. Okay. So for that what we can do? So you can take some extra array, let's say delete array, which is of type boolean. So everything will be true initially. Okay. Now we should somehow mark this as false and this as false. Okay. So that we will understand like we shouldn't delete these two indices. So can we do something with this? So please pause here and see how can we mark these two indices to false. How we can achieve that. Okay. Now let's take two pointers, one as I and other as j. Okay. Now whenever I match two characters, what I do is I'll mark it false. Okay. I will start I from the last character of A and J from last character of B. Whenever two characters match, I will mark to false. I'll move this two pointers towards backside. So if they don't match, now what I should be doing? I will keep moving I unless it matches. Once it matches again, I will mark it false. I will move it back. So if you see, should I keep traversing till 0 for I? No, right? Because already J reached -1 and there is nothing to compare. Yes or no? So these will be indices 0, 1, 2, 3, 4, 5, 6. Okay. So we can stop here. This way we can know we can delete all these indices except for these two. And but and other way what we can do is we can simply maintain some set, unordered set, and every time we instead of having this delete array and marking them to false, every time we can store these indices. We can store indices 3 and 6 in set. Now once we got this, now what we can do? Let's say we have this set instead of this delete array, we have that set. Okay. Now what we can do? So we shouldn't be deleting these two indices. What we should be doing? So can I simply say every time we keep moving forward, uh, we need to add some value. Okay. So let's take two variables. One is answer and other variable, let's say index, which is initialized to 1. So every time what we do is we go to this particular index, we see this index is present in set or not. If it is not present, that means we can delete that element. So simply I will add index to answer. Okay. Again I move forward. Again I move forward. So again I will check whether index 1 is present in set or not. No. So we can delete it. Again I will add index to this. It will become 2. So again I will add index. It will become 3. Now the moment when I come across a particular index which I shouldn't delete. So what happens? Previously when I'm deleting this, this is becoming index 3. Again when I'm deleting this, index 1. Again when I'm deleting this, index 1. Now when I don't delete this element, when I don't delete this element, the next element will be this that I am going to delete. Yes or no? So this will be index 1, this will be index 2. Yes or no? So from now on, will we delete index 1 or 2? 2. Yes or no? Again, we delete this, then this will become index 2. So simply, once we come across index which is present in set, we simply increment index. Okay. Again here, this index, is it present in set? No. So add 2 to this. Again, increment, is it present? No. Add 2 to this, 7. Again, B, can we like is it present in set? Yes. In this scenario, what we should be doing? Again, we should increment this and increment I. So finally, we came out of loop, and answer will be 7. Okay. I hope everyone are clear with approach. Let's quickly write code for this. Okay. Let's quickly write code for this. So firstly, let's take t, then let's scan t, and let's look for t times. Now, take two strings a, b, scan them. After scanning, let's call a function cost, and let's pass these two strings. Let's also and let's assume it will return us some answer. So should we return integer? Can we return integer? And if you observe carefully, constraints are big. Okay, the constraints are big, so it might exit integer limit. So instead of int, let's take long. Okay, cost. Let's take string a, then b, then let's take n as a dot, then m as b dot. Okay, let's take not man. Let's take it. Now let's take I as n minus 1 and j as m minus 1. Let's run a loop where I greater than or equals to 0 and j greater than or equals to 0. So we'll be having two cases. One, if a of I equals to b of j. In this scenario, simply what we can do, we can insert the particular index. Now, can I simply say we can decrement j, and I, can I simply say we will decrement it even if it matches or not? Yes or no? It doesn't matter. So we'll have it outside condition. Now after doing this, let's have a quick condition like if you are having, if you consider this case, so can you tell me what happens to I and what will be the value of j after while loop? Can I simply say j will be pointing to e, that is nothing but 0, and I will be pointing to minus 1. Why? Because we don't find e in a and we keep traversing backside unless it becomes minus 1. So in this scenario, that means if j is greater than or equals to 0, that means that particular element, particular index element is not present in it. So in this scenario, can we simply return minus 1, that it is not possible to convert or transform string a to b? Yes or no? Now let's take two variables. One is, let's take answer and let's take index. Now let's write a loop. Every time what we are doing, we are having two scenarios. If the index is not present in set, if the index is not present in set, what we are doing, we'll be simply adding idx to answer. Else what we'll be doing, we'll simply increment index. Okay, finally return answer. Let's submit the code. It got accepted.
So that's it for today, guys. I hope you liked the video. Thanks for sticking till the end. If you found these solutions helpful, don't forget to like the video and share it with your fellow coders. Also, hit the subscribe button to stay updated with all the latest coding contests and solutions. And please let us know in comments what other content would you like us to create. Until next time, keep coding and keep improving.